Alright, in this video we're going to look at a little tougher derivative. So in this question, they want you to derive f of x equals ln 1 plus root x squared plus 1 plus e to the power of root 1 plus x squared. Kind of complicated. This is probably something you'll see on a final exam, I would say. So again, it looks hard, but just treat it as something that you've seen before. Break it down into lns and e's. Make sure you know how to derive lns, make sure you know how to derive e's, and you'll be fine. Okay? So let's recap. The derivative of ln of x, right? What is the derivative of this? This is nothing more than what? 1 over x multiplied by what? The derivative of the inside. So by x prime. Okay? So derivative of ln of x has two parts. 1 over the expression multiplied by the derivative of x. Okay? So that's lns. What about e to the 3x dx? This is nothing more than what? You bring down 3x. Bring down the 3, multiply by the original expression. Okay? So let's remember that. So let's do the first one. So f prime of x. So we're going to take care of the first part. So ln of this whole expression is essentially going to be 1 over the entire expression. 1 plus square root x squared plus 1 multiplied by the derivative of the expression itself. Derivative of 1 goes away. Root of x squared plus 1, well, we can rewrite this as what? X squared plus 1 all to the 1/2, right? And we have to derive this. So we bring down the 1/2, right? Chain rule. Bring down the 1/2 multiplied by what? X squared plus 1. So bring down the 1/2 of this expression to the minus 1/2, right? Because we do 1/2 minus 1. And don't forget, you have to derive the inside, guys. Okay? Chain rule. 2x. Do not forget this step, please. Times the derivative of the inside. So this is our whole ln expression. Plus, let's do the e part. Remember, e is e to whatever this is. Well, what's the derivative of 3x? It's 3. So that's what comes in the front. So you're actually deriving this part. So how are we going to derive this? Well, I can rewrite my e expression as, I'll rewrite it here. So this part here, I'll rewrite it here, okay? Just so you see what I'm doing. E to the 1 plus x squared all to the 1/2. Okay? So we can derive this part by what? Bring it down. E to that expression. So what is that going to be? Okay? So what we're going to do is essentially mimic this. So we'll have to pretend that this is down and derive it. So we'll have 1/2. Okay? 1 plus x squared to the negative 1/2 times the derivative of the inside. 2x. Okay? And what are we forgetting? The original expression multiplied by e to the what? Original expression, which was what? 1 plus x squared to the 1/2. Okay? So let me rewrite this for you guys, okay? Because it's kind of messy. I'll clean it up for you guys. So the overall derivative, if I can just erase some stuff here, okay, I'll choose a different color for you guys. So if I clean this up, I'll get f prime of x equals, the ln part was 1 over the expression that was already present, right? Multiplied by the derivative of that expression, right? Which is 1/2 times x squared plus 1 to the minus 1/2 times the derivative of the inside, which was 2x. Okay? Plus my e part, so this is like my ln part. Okay? Then my e part is going to be here, the e. So remember, derivative of e is the exponent, you bring it down, derive it, times the original expression. So how are we going to derive something that looks like 1 plus x squared to the 1/2? Well, bring down the 1/2, multiplied by what? The expression that was already there, 1 plus x squared to the minus 1/2, because you have to subtract by 1, times the derivative of the inside, guys, do not forget, 2x, and then what? Multiplied by the e part. E of what? The original expression, which was right here. 1 plus x squared. And instead of the 1/2, I'll just put minus square root. Easier to see. Okay, guys. And for simplicity's sake, you can probably leave it like this. If your teacher wants you to simplify, well, you can factor out a common factor. You do have 1/2 times x squared plus 1 to the negative 1/2 times 2x, common in both. You can factor that out, depending on your teacher. I would not take marks off for leaving it like this. If you do this, you show a good understanding of differentiating lns and e's. Alright, guys? So you are done here. If you have any questions, don't be shy to send me an email about this question. I'll be glad to answer you guys. This is a question you'll see for a Dawson final, a Champlain final, even Vanier and Marinopolis. So very similar to all the Cal type exams that you'll be able to see. All right.